Welcome everybody. This is the Tampa Bay DevOps meetup. Hope everything is going well during our COVID situation. Kind of get into it so we can get the presenter going. He has a lot of great content that we're going to be talking about, but this meeting will be recorded and we'll post it up on YouTube. Just some quick guidelines for the call. Please keep your phone on mute and the settings on mute unless you're talking. So if questions are being asked, if you want to raise a question, feel free to come off mute, ask questions. But if you're just going to sit there idle, please keep it on mute so that we don't interrupt our presenters. And we encourage video. So if you're going to ask a question or just want to turn your video on, that's great. It feels like it's more socially engaging. And if you have any questions, feel free to ask and or put them in the chat window, and we'll keep an eye on that and make sure that they get answered throughout the meetup. We do have a little bit of a raffle on this one for some t-shirts and a Echo Dot, I believe it is. And I'm going to let Ari talk a little bit about that and share some stuff about JFrog.
Yeah, I appreciate that, James. Thanks again. Let me just share my slide here. And hey, everybody. My name's Ari Waller, and I have the privilege of being the meetup event manager for JFrog. And we're really excited to have Baruch speaking here in your community tonight and to sponsor some prizes for the evening. Though I'm sure many of you have heard of JFrog, for those who have not, we are a software company founded in 2008, based in the Silicon Valley, and best known for our DevOps tools. Many of you, I'm sure, have used our flagship product, Artifactory, over the years, which is the world's first and leading universal binary repository. Today, JFrog has nearly 600 employees, 10 offices globally, and more than 3 million developers use our software tools on a daily basis. Now, what a lot of people don't know about JFrog is that we actually have created free access to our cloud-based DevOps platform, especially for the community. You can get your hands on this if you'd like. There's no credit card or expiration dates associated with this. These tools include Artifactory, as well as some extra vulnerability scanning and some CI/CD pipeline capabilities for you to play with on some of your projects if you want to work on some stuff. Now, I know you're going to be enjoying a talk from Baruch tonight. This is one of my favorites. But in addition to this, JFrog is excited to give away an Echo Dot as well to a lucky winner. You can enter with the QR code or the bit.ly link that you see on the slide. I'm actually going to drop it in the chat, and also Baruch is going to share another link with you, but it's going to get you to the same place. A winner is going to be selected for the Echo Dot in the next 2 business days, and we're going to share the winner's name with Tampa Bay DevOps on your meetup site, and we'll probably congratulate you on social media as well. Now, there's really no losers tonight because anyone that enters the Echo Dot contest tonight is going to get a free JFrog t-shirt. So that's why we asked for your address. I'm not going to send you anything else. I really don't, we don't send out mail. But anyone that enters, we're going to send you one of our Iron Frog t-shirts. And if you look to over my shoulder over here, you're going to see the Iron Frog t-shirt. He's really cool. And that's the one that you're going to get just for being here tonight at the meetup. So anyway, James, again, thanks for having us and thanks for including us in your community. And I'll turn it back over to you.
Awesome, and I do appreciate that. And I was actually lucky enough to win a t-shirt at another event. And I do say it's nice and soft, good material. It's a great little t-shirt, and who doesn't love Iron Frog, right? But, quickly getting into it, Baruch is going to talk about DevOps patterns and anti-patterns for continuous software updates. And we're going to talk about how to, update faster and deliver faster with quality. So Baruch, I'll hand it over to you.
Thank you, James. Thank you very much, Ari. Let me share the right screen. It will be this one. Here we go. Let me put you all to another screen. So if you have questions, I can look at you. And you see the slides, right? All right, perfect. Okay, so we should get started. And today we're going to talk about, how we update software fast, secure, with good quality and everything else. But before we dive into how to update and how not to update, let's talk about why. Let's talk about why people why software updates are important. And well, obviously there is some software that is not getting updated. A BC that you probably know, it's a command line or command line calculator. And it haven't been updated for 20 years. And there is a good reason for that. The basic rules of math didn't change. The shell didn't change. There is no real reason to update, and that's fine. But that's an exception. The majority of the software, we have powers that force us to update software. And one of those powers are users, are us. We demand changes, we demand new features, we demand more features, we demand them now. And right, so we want features and we want them, obviously we want them now. So that makes sense that if the users want as many features as possible, it's our responsibility to go ahead and update the software so the users will get more power. Other reason is security. Now, fairly enough, some of the industry might say, well, you know what, this market pressure doesn't apply on us. We don't have competition, our feature set is stable, actually what we do just works and we don't have to do any updates, to add any features, and that kind of makes sense. And I will give you one example of such an industry that don't have the pressure for new updates, and that's you guessed it, the credit agencies. They don't need to provide any features. They are not really like user oriented. They do have a website, but there is nothing you can do on this website, and they manage those, you know, the credit records, and it's an oligopoly. There are 3 companies. They don't have any competition. They really don't need to release faster. They don't need to provide any updates. They don't have this market pressure to release faster. But interestingly enough, the same muscle, if you wish, that knows how to update and gets weaker if you don't, is used when you need to secure your software and make sure that you deploy security fixes as hard as possible. And you know where I'm going with that? Equifax 3 years ago, and their inability to patch a simple Java dependency, struts, for months, which ended up obviously in millions of credit records flowing to the hands of Chinese government, and the resignation of a lot of top executives of Equifax, including their CEO. So why it happened? What's so hard to update? Well, they never updated because they never needed to, because no one cares how their product looks like and they don't have competition. But it's the same thing too for security updates. So we can look at the State of DevOps report that you are obviously all familiar, this huge research that used to be done by DevOps Research and Assessment Institute, and then Google Cloud, and now hopefully GitHub will produce something of a sort, 31,000 survey responses, very serious. We could look at the results and we can see that every 5th organization, 20%, are what are called elite performers. And elite performers, what do? They update their software faster. They update it so fast that it's actually, they do it on demand whenever they like. And this obviously allows them to both provide features much faster than the competition and also provide a security response faster than, well, not faster, but as soon as possible, and defeating the attacker, obviously. So the reason why every 5th organization is already know how to do it, because it's not a new idea. And we are talking about decades. Extreme programming, 1998, was talking about shorter feedback. Scrum, reducing circle time. Toyota production system or lean manufacturing, decide as less as possible and deliver as fast as possible. And Kanban, incremental change. All those methodologies are talking about the same thing. Release faster, update faster, shorten update cycle, etc., etc. So let's talk about that. My name is Baruch Sadogurski. I'm the Chief Sticker Officer of JFrog. So if it was in person, I would obviously enjoy Tampa Bay, and I would bring you some cool stickers. For now, I'll have to enjoy this virtual conversation and serve as the head of DevOps advocacy with JFrog. Ari spoke a little bit about JFrog, so I can skip that part. My Twitter handle is jbaruch, and you connect with me there. If you're still not convinced that you need to follow me, the Twitter handle is in the bottom of every slide. That's my California disclaimer. As you can see, the most emotionally expressive and confrontational people are from Israel and Russia. I managed to be from both, so it might be that I offend you in any way during this talk, and I really don't apologize. So anyway, this is from an amazing book called The Culture Map, that if you work in multicultural environment, and you really should read. And where can you find a link to this book? Well, I have a slide for that. So if you go to jfrog.com/show notes, you will find there the slides already available, the video that I hope James will share with me that I will upload as soon as it's available, all the links, including the culture map book and everything I mentioned before, which is the state of the report, and everything that I'm going to mention throughout this talk, everything is already there. Also a place to comment, to rate, and the raffle that, again, Ari already mentioned with the t-shirts and all the great prizes, everything is there. So with that, let's talk about how we can update faster. We want to be one of those elite performers. We want to update on demand. What can possibly go wrong? For an example, I want us to look at Java. And regardless of what are you a Java developer or not, you know about Java, obviously, and you might heard that 3 years ago, more than 3 years ago, 3.5 almost, Java decided, and Mark Reinhold is the head of Java platform at Oracle, decided they're going to release faster. It came after very long releases, basically years, but then Mark said no more, we're going to release every 6 months. And they did deliver on their promise. Java 8 was when this blog posts were out, when they changed the cadence, and then Java 9, Java 10, Java 11, Java 12, Java 13, Java 14, and Java 15, 7 new Java versions out there since the announcement that they're going to update faster. Now let's see how well they did. And we can look at the State of Developer Ecosystem Report 2020, just published maybe like a month ago by JetBrains. Again, serious survey, almost 20,000 people. And you can see that 75%, 3/4 of the market, are still on Java 8. The same version that was released when Mark said, okay, now we're starting to release fast. And you wonder, how comes? I mean, I hope what I said earlier about how important it is to update makes sense. And then you look at the company that really stepped up their game in releasing software, and no one takes it. To understand why, we need to look at how we decide if we want to update. I apologize that my diagram will be from right to left. It's my Israeli roots probably speaking, but here you go. Let's say update is available. The next question would be, do we want to take it? Some updates just don't bring anything good. Think about, again, if you know Java, think about Java 9. It was just bad. So we just say, nope, I'm not going to update. but sometimes there are features that you want. And then you're like, oh yeah, I want those features. And the next question is, are they higher risks? Examples of environment without higher risks in which you will say, yeah, sure, let's update. For example, your developer machine. You can install there a latest version of Java the day it was released, or even maybe a beta, and play with it and see how do you like it. Because why not? I mean, what's going to happen? You will have to install an older version if something breaks, but sometimes there are high risks. For example, your production environment. Upgrading Java in your product, in your production environment is completely different risk. And then the next question you ask yourself is, do I trust this software vendor with this update? And frankly, I cannot think about single version vendor that we trust blindly those days. But if we go a couple of years back, you can think about Apple and how their macOS operating system super critical update for your machine was as reliable that you can just go and say, yes, I want to update an hour before an important meeting or a conference call or a conference talk, because it was just fine. Yes, we trusted the update. And then we just went ahead and updated. If we don't trust the update, let's first understand why. You can say, well, the quality is not good. But why the quality is not good? What happened? I mean, that's the same vendors that we used to trust, and they get better with the QA over time, not worse. So what changed? And I would claim that what changed is the complexity of the software that makes testing and quality assurance harder and harder. So for example, the amount of data. It grows exponentially. It grows to absolutely astonishing numbers. 175 zettabytes by 2025. Just for you to understand what zettabytes are, that's not what comes after petabytes, which is in our book Big Data Today. After petabytes are exabytes, and after exabytes are zettabytes. That's absolutely astonishing, mind-boggling amount of data, and that means that more and more companies have so much data that it doesn't make any sense to even try and emulate anything remotely similar to production environment in their staging servers. And that means that the staging servers, as we know them, and that means actually a clone of production environment, do not exist anymore. Which brings us to the next conclusion. If we cannot replicate the production environment, we cannot make sure that everything will work in production as expected. And that means that we will have problems going into production. And that's one of the reasons why we don't trust the vendors. So the next question is, once we set up that we don't trust them, the next question is, can we verify? Sometimes the verification process is just too long. If it will take me to verify that everything works after a Java upgrade more than 6 months, and in 6 months it will be a new version of Java, then the question is, why do I even bother? Because by the time I will end up with verification, there will be a new version to verify. So I might just say, you know what, I'll just skip a couple of versions. They are not very critical for me, and the verification is not worth it. And even if I decide that I do want to update, then it will cost me a lot of time and money. So now what the vendors can do in order to kind of convince us to update. What they can try and do is put more food on the table. Make the update more interesting to us, kind of lurking us into update. There is this trade-off between the features that we really want and the acceptance test costs that the vendors try and break by making the updates more lucrative and adding more and more into updates. But the problem is that they achieve exactly the opposite, because they go into this spiral of heavier and heavier updates. So the users don't update, and then the vendor decide we're going to add more features to each release. But then updates are even more dangerous because they are bigger, more complicated, and will take us even more time to verify. And then we defer the updates, and this is how this spiral goes. So the question is how we can cheat, if at all. Is there any way? So first of all, we can do is auto update. We can say, you know what? We don't ask you if you want this or not. We are just going to update that. And this works for everything that is not high risk. And I will give you a couple of examples. Chances are you don't know what's the version of your browser today. Being it Chrome or Firefox, they are auto-updated and you don't even know which version is it. For sure, you don't know what's the version of any web app in your browser. But that's again very low risk. Like you have this sandbox of a browser, but generally speaking, a web app cannot break your production systems. So that's kind of a low risk, and this is why you don't know which version of Twitter you use, and they don't ask your permission to move to a new version, even if you hate the new UI. The same with most of the mobile apps. You don't really know what version of Twitter your iPhone or Android application is running, and you frankly don't care. Again, if it's broken, you are going just to do something else. If your Netflix is broken, you are going to watch Hulu or whatever you are doing. So this is fine. But when we come to risky applications, then they won't dare. And one of the examples is the operating systems of your smartphone or your computer. And I know a lot of people that still didn't upgrade to Catalina on their Mac because it's a risky update, and the risks are very high, and they are just not willing to do that. So once we established that the problem is with trust, let's talk about how companies manage to break this trust and which patterns we can learn from those failure stories in order to regain this trust or establish this trust and being among those vendors that our users actually trust. And the first example that I want to bring is an example from my personal life. That was the story of Google Wi-Fi.
For technical architect or Roblox, and all this stuff, all the toys in the back. Roblox? Let's take it for half an hour to use Roblox.
James, can you? Thank you. All right. So Google is doing, they were licensing or doing the software for self-updating routers for a while now, I think for like 5 years. It was called On Hub, and it was a router made by TP-Link and someone else, maybe Cisco, and now they're calling it Google Wi-Fi and Google Nest Wi-Fi, and they're doing it themselves. And this is an amazing system, and I use it for many years. One of the reasons I started to use it is the automatic over-the-air updates, and they are great, and they are great because all the things that we spoke about. So 3 years ago, I was on a conference, and like a physical conference or a meetup. I flew on a plane in the air like birds. It was a magic, and then I was in a venue with other people, which are not my family. That was like, phew. And then my wife is calling me and say, Baruch, I came home from work, and oh yeah, she went to the office, like work there, and then she came back home, and she's like, I came back home and kids are sitting in the dark, and I'm like, what's going on? Is there like a power outage? And she's like, no, the power is fine. They just shout, Alexa, turn on the lights. Alexa, turn on the lights, and nothing happens because there is no internet. So that day, the kids learned that there are physical switches on the wall, but also we started to troubleshoot what happened, and everything looks fine. Our provider said that they don't see any problem on their side. And then I get this email. Sorry, we tried to push an update to your router and we accidentally reset it to factory settings. And now there is nothing we can do because your router is not connected to the internet anymore. So you please go ahead and reconfigure it, which is okay. The problem is that you need internet to get an email. Well, but I was somewhere else, so I was able to get it and it's all fine. But yeah, I mean, it's a problem. And it's a less problem with the home router that is somewhere in my living room and I can go ahead and reconfigure it, but think about other scenarios. What about a solar array in a desert that it takes you 3 days to get there? Obviously, while the time you get to reconfigure it, you already suffered huge production losses. So what we can do instead, we can have a previous version saved on the device, and then we can roll them back if something goes wrong. And the thing is, it's not a new concept. This is a screenshot from Windows 98. The only reason it's 98 because I didn't find a screenshot for Windows 95. And that's a local rollback. You plugged in a new monitor or you replaced your video card. And when you change the resolution, this is what happened. It was a preparation for a local rollback in case you don't see the screen anymore, and then it will revert it back for you. Great. Why don't we do it now in 2020? That's a good question. Now you can say, well, Baruch, the Wi-Fi routers are a thing in their own. They're part of IoT. It's not really my domain. Well, I will argue that T in IoT, which is things, means all the things, including any type of software. And what we learn here, like local rollback, it's definitely applicable for the rest of the industry as well. But here's an example, another example from the IoT space, and that's cars that run on software. The first one that I want to talk about is Jaguar I-Pace. Jaguar I-Pace is an amazing, very impressive car. It was released last year, and just 6 months into operation, they discovered they have a problem with software bug in brakes. That's a pretty significant problem. What do? It also turned out that Jaguar don't have over-the-air updates. So they have to do physical recalls of all the cars. I guess, but they didn't sell that much back then, but still, all the cars, and then fix the software, update the software manually. And manual software are bad because they require physical recalls. And physical recalls are very costly. And also the problem is that you cannot force an upgrade. What are you going to do? You're going to send them a mail in like a red envelope written in caps, calling them to come and fix. Some of them will come and fix, others won't. You cannot force it. Instead, software updates. Software upgrades are great because you can enforce an upgrade and fix the problem with the brakes for everybody. The only thing that is better than software updates are continuous software updates. And continuous software updates are better because, let me give you another example. Let's talk about Tesla. It's amazing. And Tesla obviously does over-the-air software updates, but they are not perfect. And here's one example, what is called the phantom braking. The phantom braking is when someone drives the Tesla car with autopilot and suddenly Tesla slams, the autopilot slams on the brake without any visible reason to do that. And there was a rumor that there is a fix for phantom braking that is coming up, and obviously the users waited and waited and waited, and it took weeks. It took weeks until the update was actually out. What is the reason? The reason is chess. The same update that they had this minor improvements and bug fixes that allegedly fixed the phantom braking also included the big, like the highlight of this update was chess. So people who have Teslas and need to charge their cars, they can play chess while the cars are charging. And obviously it was very big outcry, why we waited for the phantom braking fix. We waited until you finish chess. But actually no one knows. Maybe it was the other way around. Maybe the chess was ready a while ago and the fix for the phantom braking took time. We have no way to know, but it also doesn't matter because there are other users of Tesla who are smart people. They play chess and they also know not to use the half-baked autopilot on Tesla because they're smart. So they don't really care about phantom braking, but they do care about chess. And they might very well be frustrated why releasing chess took so long and why they had to wait for the stupid phantom braking thing that they don't even care. What I want to say is no matter how do you define what is important for you in software update, if you batch the updates, the important features wait for non-important features. Again, regardless of what you as a user think important, because people are different, important things are different for different things. Instead, continuous updates mean release what you have. You have chess, release the chess. You have a fix for phantom braking, release that. It's the other way around, actually. The phantom braking fix is ready before chess, release it first, and release chess after. It doesn't really matter what's the order. What matters is that you need to release once you have it ready. So that was kind of a little bit of more abstract examples for you, the people who work on like a server-side classical software and are not really into IoT or updating cars. But I will give you a couple of examples from our very own domain. And the canonical example, it was a long time ago, and probably most of you heard of that, but it's still worth reiterating, the Knight Capital story. And we're talking about 2012, a huge, a very large trading company on a New York Stock Exchange decided they are going to update to a new trading software. And it's been years, I think like 7 years since their last update. And they worked on this new software for a very, very long time. And they decided that the new systems are going to reuse some old APIs, but they're going to do something completely different to the extent of selling instead of buying, or just selling in the wrong time, or buying in the wrong time, or something like that. And they accidentally forgot to update one of their 8 servers. And then when they started to, when the trade day started, and they saw that something is wrong. Some part of the new clients actually send their request to old code, and then the system does something wrong. So what did they do? Well, they undeployed the rest of the 7 servers because something is wrong, so we need to undo what we did. But now all the new clients sent 100% of the requests to their own code, to the non-updating server, and they didn't have any monitoring or debugging or alerting, and it took them 40 minutes to understand what's going on. They lost more than 400 millions during this time and eventually went out of business. There are tons of learning to do here with Knight Capital. I think that the obvious ones, automated deployment. I mean, people suck at repetitive tasks, and it's not a surprise that they forgot to update one of the servers. And the solution to that is don't do it manually. Automate the deployment, and the machines won't forget the 8th server. Another reason that contributed to how badly this software update went was the frequency of the updates. Seldom deployments generate anxiety and stress and leads to errors. They didn't update their software for years. Probably the last person that knew how to update their servers left a long time ago. So instead, if it hurts, do it more. Update frequently to develop skill and habit. And remember, when I told you, you might have industry that doesn't require updates and it's still worth it to learn how to update. This is one of the reasons. When you do it often enough, it's not a big deal anymore. So when you have a real update, for example, security vulnerability or major software update, it's not such a big deal. So you do it easily. Well, state awareness, again, I assume that there were good reasons to reuse the state of the old system, but what you need to remember is that it has side effects. And more so, not only you need to remember that it has side effects when you update, you need to remember what side effects there were when you are going to revert, because reverting might require reverting the state. It's a very, very interesting use case. I recommend everybody who are not familiar, go ahead and read. You know where to find the links. If you go to jeffrey.com/show notes, you will find there all the leads, all the links, including the link to the Night Capital story. Moving on to a modern era, if you want, from 2012, last year, July 2019, Cloudflare took down a huge chunk of the internet for 30 minutes. What happened? Well, Cloudflare, they deploy rules for routing to battle internet attacks, DDoS attacks, and others, and they do it all the time. And one of the, right, so this is what they do. So they misconfigured a single rule, and it was a regular expression which went wrong. It spun the CPU to 100% and created a chain reaction. Next thing you know, the status page says affecting region Earth. And here, I guess the lesson that we can learn is the lesson of progressive delivery. Releasing bug affects all the users, and the way to release, so to prevent it, is releasing to a small number of users first, effectively reducing the blast radius. And then you observe if everything works well, then you continue with the release. Otherwise, you stop the release, you revert or update the affected users. Now, the story of progressive delivery is also not a new one. Each and every one of us learned about progressive delivery where we were about, like, I don't know, 8, when our parents taught us how to do laundry, because on every fabric treatment, you will see this warning: always spot test on a hidden surface test first. This spot test is exactly progressive delivery. Then you decide, after trying on a small spot, if you want to continue with the delivery of the fabric treatment or not. Obviously, once you tried, you need to look what reaction it caused, and that's observability. Because if you don't have observability, you can only hear about your problems from unhappy users on Twitter. And that's not a very reliable feedback to debug based upon. So instead, implement tracing, monitoring, and logging, 3 tiers of observability, and that's obviously how you know if something is wrong. Now, when the problem occurs, you might want to roll back instead of creating a fix, just because rolling back is faster. So you implement rollback, the ability to deploy a previous version without delay. It's not always possible. So for example, if you are a mobile developer and all your target platforms are Android, Google Play Store, and Apple App Store, none of them support rollback. You cannot roll back. You have your previous version that you need to rename to like the next version, and then you submit it for review. It takes them what it takes, day 2, 3, whatever, and only then you can it will be shown as available for upload, which obviously is not a very good pace to fix a bug that you just released in production. So instead, you can use feature flags for progressive delivery. You can embed 2 versions of features in the app, and then the old one and the new one, and then use the API to trigger. So if there is a feature that doesn't work, you can turn it off for the affected users without needing to redeploy. And now to the funny part. Exactly a year later, July 2020, Cloudflare did it again. Now, it did it again to a very, very funny level. They did a maintenance on a New York-Chicago segment of their infrastructure, and the engineers wanted to reroute the traffic that goes from New York to Chicago through Atlanta. Guess what happened? They updated the config manually, and they made a mistake in the regex, and they managed to route all the traffic through Atlanta. Not only the segment New York, Chicago, but all the traffic in the world. Obviously, Atlanta crashed, and then it was rerouted to the next one, chain reaction, everything else crashed, affected region Earth. What can we learn from here? What we already learned: automated deployment. People suck at repetitive tasks, automate everything. So just to summarize, what are we talking about, and what do we need to achieve continuous updates that will restore the trust between the producer of the software and the consumer of the software? The updates should be frequent, should be automatic, should be tested as much as possible, should be progressively delivered, should be state aware, should be observable, and if possible, should implement local rollbacks. That's kind of an extra credit task, but still completely doable. And then if we manage all that, we believe that we can reestablish the trust. So no one wants to ask us if we want the software, but regardless of if we have high risk or not, the answer will always be update, because we trust the updates. So our goal is to transition from bulk and rare software updates to extremely tiny and extremely frequent software updates, so tiny and so frequent that they provide an illusion of software flowing from developer to the update target. We call it the liquid software. The name for the vision came from one of JFrog co-founders, Fred Simon, and Fred, together with another co-founder of JFrog, Yoav Landman, and yours truly, we wrote a book called The Liquid Software. And this is a book about continuous updates. And Ari spoke about all the prices for the raffle that you can get when you go to jfrog.com/show notes. But here is another one. If you want to, ping me on Twitter, direct messages on Twitter at jbaruch, my direct messages are open, or find me on LinkedIn or in any other way, and I will be happy to send you a physical copy of the book to your home so you can learn more about liquid software and continuous updates. And before we are wrapping up, I wanted to talk to you about the corner cases. And we obviously acknowledge that they exist. For example, probably updating that requires downtime that needs to be performed on the medical device during a surgery. It's not the best way to update software. But what I want you to think about is how many corner cases actually exist. And I would claim that there are much less that it might look so. And I'll give you an example. What do you think about updating a plane mid-flight? Is it a good idea? Is it a bad idea? Is it even doable? Should we dare and think about it? So 2 points of reference. Airbus A350 has a memory leak. It needs to be restarted every 149 hours. You might say, huh, I won't ever fly with Airbus A350 anymore. But how about Boeing 787 that has a register leak and needs to be restarted every 51 days? Now, let's say you fly from San Francisco to Australia, and you are over the Pacific, the biggest ocean on Earth. There is no land in sight. You passed Hawaii, and then the co-pilot asks the pilot, hey, by the way, did we remember to restart the plane because our 159 hours are almost up? And the captain, oh no, I think I forgot it. Wouldn't it be nice to actually update the plane mid-flight and push the fix for the memory leak? I think we'll agree that that would prevent a catastrophe and it would be nice. Now you might say, you know what? It's nice that you have a dream, but it is not actually possible. And I will tell you, not that it's not possible, it has been done for 20 years already. During the design of Boeing 777, which is like 20 years at least, I think, they had a problem with turbulence control software, the control software that helps the plane to stabilize during turbulence. And they couldn't debug it on the ground. So they took all the development team on board. They took off. They flew to the area where the turbulence was. They debugged it mid-flight. They patched the bug, the plane mid-flight, and verified that the issue is gone. And that was decades ago. This example is from a great book called The Project to Product by Dr. Mick Kirsten. And again, if you go to Jeffrey.com's show notes, you'll find a link to this book there as well. So with that, I hope I convinced you that liquid software is a good idea, and doing it most of the time is great, even when you are not sure. And you can follow me on Twitter at jbaruch on Twitter. I remind you, this is also where you go to get the copy of the book. When you talk about this talk on Twitter or on LinkedIn, please use the hashtag liquid software. I think the hashtag for this meetup is TBDevOps, but I'm not sure. But if you are not sure as well, you can very well use this one. Liquidsoftware.com is the official website of the Liquid Software Vision, and you go to Jeffrey.com's show notes for the slides. Hopefully the video will get there soon once James shared it with me, and all the links, that everything that I mentioned, and the raffle for Jeffrey t-shirts and other prizes. With that, thank you very much. And now let's talk about it. Feel free to turn your camera on, get off mute, and ask any questions if you have any. Thank you. Or we just can go with our day. That's also fine.
Any questions at all?
What about potential bugs in the rollback process or software itself?
Yeah, that's a great question. And that's, I think, a recursive problem, right? What happens if when I try to fix it, I actually, my fix is not good enough, or break stuff, or I'm failing in a rollback, and the only answer is, well, two answers. First of all, practice, 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 and second is observability. In the end of the day, if you roll back and what you rolled back didn't work as well, the same observability techniques will alert you that something is bad happening. then you are in kind of a problem because your plan B, your backup plan was the rollback and it didn't work. And now people will suffer until you fix and deploy the fix. But here again, we're talking about how important it is to be able to deploy or update as fast as possible, because if your rollback fails, your next opportunity is a new update that you need to release as fast as possible.
Okay, so I have a second question then.
Sure.
Do you think it's feasible or possible to even conceive of building a model, a digital twin, if you will, of the systems that we're tasked with maintaining, so that we can conduct a dry run and fail in place, fail early and fail often?
That's exactly, but that's staging, right? That's exactly what staging was supposed to be. It's an identical twin of production system that we update first and we check that everything works, and then we have more confidence in going to production. The problem is staging for a lot of companies, and this number is increasing, doesn't make economical sense. It's too hard to build and too expensive to build. And I mean, I wish for us, it would be great if we could say, you know what, no pressure on the software providers. All the consumers will have staging and they will test it. And we as providers fucked up, not a big deal. It won't affect anything in production. Unfortunately, we see more and more companies or more and more customers, more and more consumers of our software that say we cannot do staging. And then it means that we need to be very careful in how our software will be deployed into our users' production systems. And if we can ensure and show and build the trust with the users that we know how to update their software, and all those techniques that I mentioned is exactly the part of it, then we can build this trust and say, you know what, you can count on us that our updates won't be catastrophical, even if something bad is happening. That's what this talk was about.
Thanks, appreciate it.
Yeah, great questions. Appreciate that. Anybody else? Now's the time.
I have a question.
Sure.
It's kind of following up on stage environments. I know, like for instance, Microsoft updates, right? They do frequent updates, and we are all experiencing some of the challenges related to updates to the operating system. When you're dealing with non-heterogeneous hardware, it's always a challenge to be able to reproduce all the possible combinations, right? It's not always feasible to have an exact copy of everybody's different configurations of software and hardware.
Absolutely. That's the point, right? This is why staging is dead, because it's getting harder and harder to be able to build an environment that will create a copy of your production, because software gets more complicated, clients get more diverse, et cetera, et cetera. Absolutely.
Yeah, at some point it becomes non-deterministic, and extremely non-deterministic in some cases.
Yeah.
Awesome. We are right at 6:30. Any last final questions? Awesome. So we will end the meetup. I really want to appreciate it. Thank you, Baruch, for doing this for us. This was a great talk. Appreciate the insightful information that came out of it. We will get that up on YouTube as well as provide you a copy.
Yeah, YouTube is fine. I will just embed the YouTube on the show notes page, so everybody will have one place to go for the slides, the video, and the links.
Perfect. I will do that and get that out to you the next couple of days.
Sounds good.
If anybody has any questions, I'll also, right before I exit off, put in the notes here, and as well as through the meetup channel, just some additional resources where the YouTube video will be, as well as our LinkedIn channel and our Twitter channel.
Hey, James. I'll leave the raffle up for another half hour or so. If anyone wants
perfect.
to get that T-shirt and enter in for the Amazon Echo Dot, right now there's a few people have a really, really good chance to win. So, anyone else that wants to enter, please do so, and we'll keep it up but only share it for people that are here. It's not for the people that couldn't make it tonight. It's only for you all. So,
Gotcha. Actually, I think I'm most interested in the book.
hey,
Yeah. So that's what I wanted to remind you. DM me on Twitter, DM me on LinkedIn, wherever you can find me with your shipping address, and I will be more than happy to ship you the book, for sure.
That'd be awesome. All right. If no one else has any questions, I appreciate it. And we will meet next month. The topic to be determined. And just want to say another thank you for Ari, Baruch, Jay Frog for coming out and doing this.
Thank you for having us.
have a great night.
Right.
Thanks, guys.
Bye-bye.